Hello students. Today we will see one exercise problem in solving the double integral. This is a problem in exercise 15.3 in Stewart Calculus book, and this is the problem. Evaluate the double integral over d x cos y dA. D is given, D is bounded by y equal to 0, y equal to x squared and x is equal to 1. These are the boundaries of the region D. So this is the thing given. Now we need to evaluate this function, that is x cos y. We have to evaluate. So now we have to find the limit using the region D. What are the boundaries given? So using those boundaries, we need to find the limits. So we know the definition. D is a set of all x comma y such that here it is given that x is equal to 1. There is one boundary. So from that we can find the x, the boundary, that the limit for x is 0 to 1. So the limit for x is 0 less than or equal to x less than or equal to 1. And for y, it is given y equal to 0 and y equal to x square. So from that we can obviously understand that y lies between 0 to x square. Therefore, we can write the limit for y as 0 less than or equal to y less than or equal to x square. So now we find out the limits for x and y. So now we can evaluate, that's all. So first it is given the function is x cos y dA. Therefore we can apply the limit for x as the outer integral limit. Therefore integral 0 to 1, and the inner integral limit is given for y 0 to x squared for the inner integral. Then x cos y dy dx. Now this is an evaluation part, how to evaluate this integral. So first we have to integrate the inner integral first. So here the inner integral is with respect to y. So we have to integrate with respect to y. So first the function is x cos y. Therefore we have to integrate the function x cos y with respect to y. So we all know that while integrating with respect to y, x will be considered as a constant. So here also x is keep as it is, that is we are considering it as a constant. So we have to integrate only cos y. So what is the integration of cos y? It is the formula we have to apply. Integral cos y is sin y. Therefore x sin y into dx. So now we have to apply the limit for y, for this sin y. Sin y is the integrated part. So we have to apply the integral. We have to apply the limit 0 to x square for this sin y. So as usual we are applying the limits. Therefore first upper limit minus lower limit. Therefore we will get sin x square minus sin 0. Sin 0 is 0. Therefore we will get only x sin x square into dx. So this is the single. Now the double integral, it becomes a single integral. Therefore we have to integrate this with respect to x. So we know the limit for x is 0 to 1. So first we have to integrate, then we have to apply the limit. But here the function is x into sin x square. That is the function we have to integrate. Here x and sin x square. So both are, there are two functions in multiplication. X is one function and sin x squared is another function. These are in multiplication. So that is our function which we need to integrate. So how to integrate this thing? So we have to use we cannot integrate directly x directly integral of x and integral of x square. We should not do. So we have to use the substitution method here. So for the substitution method, we are assuming u is equal to x square. We are assuming u is equal to x square. So we are integrating this with respect to x. Therefore, du by dx is 2x into 2x. Therefore, du by 2 is x dx, because here sine x squared x dx is there. Therefore, we have to substitute, instead of x square we have to substitute u, and instead of x dx we can substitute du by 2. So using this substitution we are applying this thing. And for the limit also, the limit also will change, because 0 to 1 is the limit for x. Now we are changing the variable, x to u. So we are not supposed to apply the limit of x to limit for u. So we have to find the limit for u. So when x is equal to 0, what are the limits for x? 0 and 1. So first we are finding, when x is equal to 1, what is the value of u. So when x is equal to 0, the value of u is 0 square, which is also equal to 0. Therefore, u equal to 0. And what is the limit for u when x is equal to 1? So again we are applying x is equal to 1 in u is equal to x square. Therefore, again u equal to 1. Therefore, the limit does not change. What is the limit for x? The same will be the limit for u. Therefore, we will get 0 to 1 sine u into du. So now the function will become very simple function. Now it becomes very simple. So it is easy to integrate sine u with respect to u. So sine u is, integration of sine u is minus cos u. Therefore, we have to apply the limit 0 to 1 for this. So 0 to 1 minus cos u. So we have to apply the upper limit minus lower limit. Therefore, minus cos 1 minus of minus cos 0. So which is equal to minus cos 1 plus cos 0. Minus cos 1 is, here cos 0 is 1, and minus cos 1 is, we can keep as it is. So we are getting 1 by 2 into 1 minus cos 1. So this is the answer for this problem.